Good morning everyone and welcome to my video. My name is Hilmy with the student ID 2024-3244. Today I would like to present my practical report on the machine learning practicum, which in today's assignment I conducted an experiment using a simple linear regression algorithm, which I used to build a predictive model to predict log likes based on the log dislikes on the online gaming datasets that I got from Kaggle. To begin our project, we initialize the environment by importing essential libraries. For example, like we use pandas SPD for our data frame manipulation, and also we use seaborn and matplotlib for data visualization. Crucially, from the scikit-learn library, we import trend task split for data partitioning, and we use linear regression estimators for our model and evaluation metrics like mean squared errors and R2 score. These tools form the backbone of our machine learning pipeline. In the second step, we load the data set online gaming 14 April 2026 that I got from Kaggle. Since the separator is using tab, then we type the sub equal to slash t, and then we then focus on to specific uh, features, that is log likes and log dislikes, to have clean data, and then we also and then to also maintain the data integrity, we apply the drop NAE method to dropping submission values or dropping the non values. And then because in the machine learning, removing missing values is vital because the algorithm cannot perform mathematical operation on no values. And then we print our five top rows or of our data sets to checking that our data sets are already that our data set is ready to be used in our project like that. And then before training the model, we conduct EDA to validate our hypothesis. First, we generate a scatter plot, which visually shows a clear upward trend, suggesting a linear relation that, that you guys can see in here. Then we use a heat map to calculate the correlations matrix. The result shows a coefficient between the log likes and the log dislikes. Shows a correlation, shows a coefficient which is 0.6, 0.96, which is extremely high. This high collinearity proves that log likes and log dislikes is statistically significant predictor. Sorry, which this significantly high collinearity is proof that log dislikes is statistically significant predictor for log likes, justifying our use of linear regression. Next, we prepare our data for training. We define X as our independent features and Y as our target variable. To ensure the model can generalize to new data, we perform the trend test split with an 80-20 ratio by setting the 20% of our data assigned as a test set, we can objectively evaluate the model on unseen data. We also use the random state 42 to ensure that our results are reproducible. Now we move to the core of our model. We initialize the model equal to linear regression uh, and use the dot fit method on our training data during this stage. The model learns the optimal weights and bias, essentially finding that minimize the error or distance between the predicted points and the actual training samples. After the training is complete, we make the prediction on the test. We evaluate we evaluate the performance using two key machine learning, that is mean squared error or MSE and also the R squared. Nah, the mean squared error is shows as the 0.5318, which is this long values is indicates that our model predictions are very close to the actual values, and the R squared shows 0.9235. This means our model is successfully explains over 92.35% of our target. And finally, we visualize the results. The blue dots represent the actual data from our data sets, while the red line in here it shows the model it shows our model predictions. The fact that the red line passes directly through the heart of the data point confirms that our model has a high goodness of fit. This proves that our linear regression model is highly effective and robust for predicting game engagement metrics. Thank you for